Okay, so this is lesson 5, evaluating logarithms. So in the last lesson, we compared the graphs of y equals 2 to the x and y equals log base 2 of x. So we learned that the point 38 on the graph y equals 2 to the x indicates that 8 equals 2 cubes. So remember, the logarithm is really asking what power do we put on the base to get y, or the answer. So evaluating logarithms by converting to exponential form. So sometimes we are just asked to calculate what a logarithm is. So to do that, you always start by, if you're just given this expression like this, log base 2 of 8, make it equal to something. Once we have it equal to a variable, then we can change to exponential form, which is what was done here. Once we have it in exponential form, we can then solve that equation by making a common base. Once we have the common base, we know that the powers must be equal. So compare exponents. And then we have our answer. Once we know v equals 3, this told us log base 2 of 8 equals 3. You can also just think to yourself, what is the exponent on 2 so that it equals 8? And the answer is 3. Okay, so some examples here. Log base 3 of 81. So one way we can do it, make this equal to v. Change to exponential form. Rewrite 81 with a base of 3. You can use your calculator to help you with that. And you get v equals 4. Now most of your calculators, you can probably type this in just as is, and it's going to spit a value out. So make sure you know how to do that too. Remember, this was also just really asking 3 to the power of what is 81. So once you get the hang of that, you can probably come up with this answer 4 right away. We're going to skip to C and D here. They're a bit of a special case. So log base 7 of 7. This is really asking 7 to the power of what is equal to 7. That tells us our exponent must be 1. So we can say this equals 1. The next one is log base 12 of 1. So again, this is saying 12 to the power of what is 1? Well, we know anything to the power of 0 is 1. So that must have been our exponent. You could revert back to this method if you wanted to, but I think those kind of just make sense from what it is. Next one, determine the value of. So this just kind of generalizes it a little bit, like those last two cases. So if we want to make this equal to v, b to the v is 1. We know that v must be 0. So no matter what your base is, if you have log base of anything of 1, it must equal 0. Next one, log base b of b. So this is really asking b to the power of what gives us b. Or if you want to change forms, b to the v equals b. V must equal 1. Of course, it gets a little bit trickier when we add some other numbers in here. So a couple ways you could think of it. This one, you could calculate this value first and then times your answer by 2. Or you could make the whole thing equal to v, divide both sides by 2. So log base 8 of 512 equals v over 2. Change forms. Now we need to rewrite this with a common base. And we can rewrite 512 as 8 cubed. So 8 cubed. Now we can make our exponents equal and times by 2. So that tells us that this whole value equals 6. Okay, b, again, these ones are a little bit trickier, so to use this method where we make it equal to a variable helps a little bit. 2 to the v equals 1 over 32. We can write 1 over 32 as 1 over 2 to the 5, which is the same as having v equals -5. C is quite similar. It would just have a fractional answer at the end. So we're going to leave that one. 4. These are some other kind of strange cases that we don't see very often, but it's easiest to start the same way. We're going to make something equal to a variable. And it's actually simplest if we just evaluate the exponent first. That's going to be simpler than making the whole thing a variable. So log base 5 of 25. Once you get the hang of this, you should see quite quickly that should be 2, right? 5 to the power of what gives us 2? Sorry, gives us 25. 5 squared gives us 25. So the value of log base 5 of 25 is 2. 5 squared is then 25. So it's easy to evaluate the logarithm first and then deal with the exponent. So same thing would go there for the other two. B says, based on your observations from A to C, what is the value of A to the power of log base A of n? You'll notice that our answer here was the same of the argument of that logarithm. So it would be equal to n, which is the argument of the logarithm in the exponent. C is kind of an interesting question. If we make this equal to v, we rewrite it, a to the v equals a to the n. Well, this tells us v equals n, and that makes sense. If I said, what's the power that goes on a to give me a to the n, it would be pretty obvious that that exponent needs to be n. Okay, on to the next page. We're going to skip this part for now. It just talks about how we cannot evaluate these things yet unless they're exact values, but we'll get into that in a minute. And your calculators are a bit different than how the workbook is set up. Here's some common logarithms. I kind of touched on them on the video from the other lesson. So common logarithms are logarithms in base 10. So example, log base 10 of 1,000. These logarithms are in such common use that when a base is not given, the logarithm is understood to be base 10. On a graphing calculator, these can be evaluated using the logarithm key. Yours, you can actually pick the base. So if you want a base of 10, most of your calculators you're going to have to put in 10. On a different style, it just assumes 10, and we have to do something else if our base is different. So evaluate log of 1,000. Well, this is really then saying log base 10 of 1,000. We can make it equal to v. 10 to the v equals 1,000. And v must be 3. Logarithms with base 10 are usually pretty simple to calculate. So in each of the following, estimate the value to the nearest number without using technology. We're not going to worry too much about this because, like I said, our calculators can do it. It's just important to know this is saying 10 to the power of what equals 89. This is not going to be a whole number, so we'll need our calculator to help us get an exact value there. So we have two special logarithms. One is the base 10. The second one is called the natural logarithm, and it's used a lot in mathematics. And it uses this number e, which is an irrational number, kind of like how pi is. We've given it a letter to represent it. And we're not going to worry about where it comes from, but it's found in nature a lot. It actually, you can enter it as log base e on your calculator. I think you can get to e, the same menu you get to pi, I believe. Sorry, unplugged the microphone. But there's also a special button that uses ln, standing for natural log. So I'm going to skip this part here. It's just a matter of punching it into your calculator. Okay, I'm going to keep scrolling down here. We have something called the change of base identity. And this is on your formula sheet. And it was much more important when we had the old style calculators that we couldn't change the base of a logarithm from 10. But now you can. But it's still important to know that we can change the base of any logarithm using this identity. Paper maker. Using this identity. So we have log base b of c equals log base a of c over log base a of b. So you notice how the base becomes what we divide by. The argument is the argument on the top, and we can change the base to anything. So if we wanted to evaluate this using the change of base, or simply if we wanted to change the base of it, it's really quite simple. We change it to log, and usually we change it to base 10 because that's how the old calculators worked, over the log of 5. And this is the same thing as log base 5 of 221. Okay, so then we also take cases like this, convert the following logarithms to the base indicated. So let's just do b here. It says log of 300. We want to represent this with base 5. Well, we can change it to any base. We use log base 5 of the argument over log base 5 of what the base was of the original. So there's no base written there, which means it's 10. Okay, we're going to leave these ones. You could change their bases so that you can calculate things a little bit simpler, or you can just punch them into your calculator.